Hello and welcome to the second day of notes where we are going to find arc measures. So today we're going to be able to calculate the arc measures in a circle and determine the two arcs are congruent. So first let's begin with some vocabulary. First term that we're going to learn is central angle, and what that is it is an angle whose vertex is the center of the circle. So an angle whose vertex is the center of a circle, and then it intercepts the circle. So it ends, the two rays that make up that angle end on the circle. An arc is a piece of a circle. So if you think of a circle as a pizza, let's say, for example, an arc would be a piece of the crust, how big or what the measure of that arc is. All right, so a minor arc has a measure that's less than 180 degrees, and its notation, so if you're talking about a minor arc, the notation is 2 letters. A major arc has a measure that's greater than 180 degrees, and the notation for a major arc is going to contain 3 letters. A semicircle is half of a circle, so hopefully you all know that a circle has a measure all around 300 degrees, so this will equal exactly 180 degrees, and its notation will also have 2 letters. In class today, I should have given you a blue formula sheet where we're going to put a bunch of formulas from this chapter. If I didn't, please remind me to do it tomorrow and I'll give it to you. But if you do have it right now, you should write on your circle formula sheet an angle whose measure, or the measure of an angle when the vertex is at the center. And that would be the central angle. So the central angle measure is going to equal the measure of the arc that it intercepts. Okay, so let's look at our first example. We're going to find the measure of each arc, and we're going to say if it's a minor arc, major arc, or a semicircle. So the first thing we're looking at is BC. Now it is important to figure out which way you're looking at BC, because if I look at this arc BC right here, that's different than if I was to look at arc BC this way. So the way that I know which one it is the number of letters used for the notation. BC here, 2 letters means it has to be a minor arc, so that means I'm taking that short red distance that's right here from B to C. Now the way I have to find that is it's going to equal the same thing as angle BAC. But I don't have angle BAC, but I could find it easily I know that this is a diameter. It splits the circle in half, so I would do 180 degrees minus 148 degrees, and that gives me that measure, which is 32 degrees for that angle. So therefore the arc is also 32 degrees. Now because it is less than 180, it's a minor arc. Okay, next CD, this arc measure right here, it's the same as the central angle that creates it. So it's 148 degrees, and again, because it is less than 180, it's a minor arc. And finally, D to B, it doesn't matter if I look this way or if I look this way, it's the same exact arc. It's a semicircle, so its measures equal to 180 degrees, and we're going to write semicircle. Next up is the arc addition postulate, and this is just like the angle addition postulate or the segment addition postulate. 2 pieces will make up the entire thing. So it does say the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So if we're looking for the measure of arc BCD, I have to look at that in the order that it's written. So from B to C to D, this arc. So I could see that it's made up of 2 smaller arcs, BC and CD. So I'm going to add those. 95 plus 114 gives me my measure, which is 209 degrees. The next part of this question is asking me to find arc BDC. So I would start at B, travel towards D, and end at C. So I have to find this blue plus the orange. The problem is I don't have the blue arc, so I have to find the measure of that central angle, that arc first. And the way I would do that is I know that this full circle right here is 360, and I'm just missing this chunk right there. So I'm going to do 360 minus 95 minus 114, and that's going to give me the blue or angle BAD, and it is 151. So now to find the measure of arc BDC, I would take 151 degrees, which is this, again, this piece right there, plus 114, and I would get 265 degrees. So the second part of today's lesson is talking about congruent arcs. So which of these is not like the other? In two of the pictures below, arc AB is congruent to arc CD. Which picture does not show congruent arcs? So the way I always want you to think about arcs is, again, the crust of a pizza. If this was the pizza you're sharing with a friend, would you each have the same amount of crust? In this one, yes, you would. Okay, so those are congruent arcs. In this next one, you have two different pizzas. However, the radius here is the same as the radius here, so the sizes are identical, and now the chunk of the angle that you cut in is 87 here and it's 87 there, so yes, they are the same. In this last picture, this is arc AB and this is arc CD. So think of it as if you had a large pizza and then threw a small pizza on top of it. You could cut the same angle, but the arcs are not going to be the same measure, so these are not congruent. Okay, so what does it take for arcs to be congruent? Well, first of all, the central angle must be the same. If you cut a bigger slice, obviously half of a pizza is going to be more than a quarter of a pizza. And then it has to be either one of two things. The same circle. Okay, so when you cut those pieces, it has to be from the exact same circle or from congruent circles. Circles that have the same size. So example 3 and 4 here, we're going to see, are the arcs below congruent, and we're going to explain why. So for this first example, AB, that arc has a measure of 145 degrees. Arc CD has a measure of 145 degrees. So the first condition is met. The central angles are the same, but now we have to see, are they part of the same circle or part of congruent circles? Well, because these radii are the same, right here, this one and this one, they are congruent circles, so yes. And my explanation would be that I have two congruent circles and two congruent central angles. And I guess here I could have really written with two congruent central angles. All right, the next example, arc MN has a measure here of 120 degrees, and arc PQ has a measure of 120 degrees. So the first condition is met. Then we have to check, are these circles congruent? As you can see, this one has a radius of 5, this one has a radius of 4, so they are not congruent. And the reason would be the circles are not congruent. All right, so the last part here, I want you guys to try these. I'll do the first one with you actually because it's a little bit different than the other problems. We want to find the measure of arc QS. So that would be this arc right here. Now we don't have its central angle, but we could find it because this arc, or that central angle and this central angle are congruent. So we know full circle is 360 minus, we already have 52 degrees taken by this angle. So we would get 308 degrees. But that's the sum of these two. If they're congruent, I would divide that by 2 and get each individual angle, and it's 154 degrees. So therefore, arc QS is 154 degrees. All right, this last example, I want you guys to try it on your own. I will only be displaying the answers, so I want to make sure that you get it right. Okay, so hopefully you did find arc LKJ. That's this arc, starts at L, ends at J, and its measure is 217 degrees. If you did not get that, please make sure you ask me in class tomorrow. All right, that's all for this lesson. Hopefully you enjoyed it as much as I did. Have a great day.